This video is about my design of a very precise mechanical joystick based on potentiometers. I tried to use existing joysticks in conjunction with my Bechele project that allows to bring puppets and models electrically to life, but I was really disappointed about the accuracy of existing joysticks on the market, so I decided to build my own. Ordinary potentiometer based joysticks use some transmission mechanics to couple the stick movement with the potentiometer rotation. Nearly all designs do this on cost of slight mechanical inaccuracies that causes an inconsistency in the relation of the stick position and the resulting potentiometer resistance. Typically, moving the stick from different directions to the same mechanical point results in slightly different resistance values. The design of this joystick overcomes these restrictions nearly fully, since the only inaccuracies of the potentiometers themselves define the inconsistency. The accuracy will be achieved using the bearings of the potentiometer as the rotation points. Each axis uses two potentiometers that are connected electrically anti-parallel. This way, the output voltage of the voltage divider can be used with a full range from 0 to full voltage. That means the resolution of the lever's full movement range may coincide with the full range of the AD converter that digitizes the signals. In reality, the joystick is very sensitive and the repeat accuracy is very good.